Hi, I'm Jim Johnson, Soils and Crops Consultant with the Noble Foundation. Today we're going to calibrate this grain drill to plant some cover crop seed. Many times you can use the chart under the lid of the grain drill to get the right idea of where to set the drill to plant the right amount of seed. A lot of times you need to use that as a starting point and calibrate from there to be sure. This cover crop seed, that's what we'll be doing, is using the chart as a starting point and adjust from there. What we'll do is we'll jack this drill up. There's a wheel, a drive wheel. Every drill, no matter what make or model it is going to have a drive wheel on it somewhere, either in front or behind, maybe on the ends. And we'll measure the distance around that drive wheel. Then we can do some math and determine how much of an acre that one row unit plants in 20 turns of that drive wheel, and do a little more math and calculate how much seed we need to catch to put out the 57 pounds per acre of seed that we have targeted for this field. So on this particular drill, we've got a drive wheel at each end. This drive wheel runs the boxes on this side of the drill. The other drive wheel runs the box on the other side. And so attached to this drive wheel is a sprocket and chain. The chain runs a shaft that turns the seed meter. What we're about to do is jack up this drive wheel so that it turns freely. Once we have it where it turns freely, we can measure the distance around it so we know the circumference, so we know how many feet in one revolution. What we need is a tape measure and a jack, either a handyman jack or a bottle jack. So we're just going to jack this up until this wheel turns freely. Now that our wheel's free, we can measure the circumference. So I'm starting at 1 foot. I'm at 8 feet and 8 inches, but I need to subtract off a foot for my tail. So the circumference of this wheel is 7 feet and 8 inches. And that's the number we'll use when we do our math. We'll mark the wheel with a piece of tape so it's easy to count revolutions. Next we need to measure our row spacing. Our width across 2 row units is 1 foot and 3 inches, 15 inches for 2 units. So we have a 7.5 inch row spacing. This is a cover crop mix, multiple species, has small grains, legumes, some other plants, broadleaves, brassicas, and we're going to plant this mix at 57 pounds per acre. What we need is enough seed to cover the bottom of the drill. This is plenty of seed just to do our calibration. Since there's no crop on the chart for cover crop mixture, we'll just use the wheat line on the chart. So here's our wheat line, and we'll follow it across, and we want about 60 pounds of seed. So we probably need to start at 14 on the index. So since we're going to use our wheat setting to start our calibration, we will set this meter lever handle at 14 on the index. What we need to do is pull our seed tubes loose so that we can catch the seed that falls out in a cup so that we can weigh how much comes out in the cup. I usually do 4 random cups somewhere that it's easy to reach. So I'm going to turn this wheel 20 times so that we can catch our seed in our cups for our calibration. So we'll do some quick math to determine how many grams of seed we need to catch to equal 57 pounds of seed per acre. For step 1, we'll take the circumference of the tire in feet, multiplied by the row spacing in feet, multiplied by the number of times we turn the wheel to get the square feet of 1 row unit of test area. For step 2, we'll take the answer from step 1, the square feet per 1 row unit of test area, multiplied by the pounds of seed desired per acre, divided by 43,560 square feet per acre, and that equals the pounds of seed to catch per row of test area. But that isn't very convenient to use since it's a decimal, so for step 3, we'll take the answer from step 2, multiplied by 454 grams per pound to get grams of seed to catch per row of test area. So let's plug our numbers into these formulas. If you recall, the circumference of the wheel was 7 feet and 8 inches. So we know that 7 feet 8 inches is 7.666 repeating feet. And our distance between rows was 7.5 inches. And we know that 7.5 inches is 0.625 feet. So the area in our field when we turn the wheel 20 turns is 7.6 repeating feet times 0.625 feet times 20 turns. This gives us an area of 95.8 square feet. This is the answer to step 1. For step 2, take the answer from step 1, 95.8 square feet, and multiply by the pounds of seed desired per acre, which is 57 pounds per acre. Then divide by 43,560, which is the number of square feet per acre. This equals 0.125358 pounds of seed to catch per row in our test area and is the answer to step 2. For our final step, we'll convert pounds to grams by multiplying the answer from step 2 by 454 grams per pound. Our final answer is that we need to catch 56.9 grams in our 95.8 foot test area to equal 57 pounds per acre. So we'll zero our scale with an empty coffee cup. And now we can weigh the seed in each of our cups, knowing that we need 57 grams. This first one comes out 55.5. That's certainly within reason. The next cup 59. Looks very good so far. Our third cup is 50. That's just a little light. And our fourth cup is 47. So we may want to increase the rate by 1 notch on the seeder and catch one more time just to be sure. Repeat the process of catching and weighing the seed until you're within 2 or 3% of your target weight. You'll need to do this every time you switch to a new seed, and that way you'll feel confident that you're putting out the correct amount of seed that you want to put out, and you'll know that when you finish the field, you'll also finish your seed rather than running out of seed before the field's done or running out of field before the seed is all gone.